Hey everyone, welcome back. So, you've been grinding hard and leveling up your integration skills, right? Well, get ready because we're about to enter a new stage in the game, definite integrals using substitution. This is where all that practice really starts to pay off. Up until now, the problems you've tackled always give you a function as the answer. But what happens when the challenge has boundaries? A clear start and a clear finish line. It can look a bit intimidating, almost like a boss level, right? And just like any boss level, it needs a special strategy. Okay, let's get straight into our mission for today. Take a look at this integral. At first glance, it seems familiar, doesn't it? You've got a function tucked inside another function, and its derivative is hanging around right there. But look closer. See that 0 and that 1? They're the game changers. They're called the limits of integration, and they are the key to this entire challenge. What they mean is that our final answer isn't going to be a function, but one single solid number. But here's the best part. You don't need to learn some crazy new skill from scratch. To beat this boss, you already have a super powerful tool in your backpack. Think of it like a power-up you've already mastered. We just need to learn how to use it in this new situation. Remember these steps? Of course you do. This is our classic substitution method for indefinite integrals. You choose u, you find du, you switch everything over to the u world, solve the integral, and then, the final move, you back substitute to get your answer back in terms of x. This should be second nature to you by now. Now, for this new definite integral level, there is one and only one critical new rule you need to learn. Just one thing. But trust me, it is the most important rule for this entire topic. It's like the golden rule for absolutely crushing this level. So, you might be wondering, why do we even need a new rule? Well, let's be super clear about this. An indefinite integral, the ones without limits, gives you a whole family of functions. That's why we always write that plus c at the end, right? But a definite integral, with those upper and lower limits, it's different. It's calculating a specific value, like the area under a curve. It gives you one single final number. The answer is a value, not a function. And that's exactly why we have to treat those limits very, very carefully. And here it is, the golden rule. I'm serious, pause and write this down if you need to. It's this simple. When you change the variable, you must change the limits. When you go from the world of x to the world of u, the limits have to come with you. Forgetting this is the #1 mistake everyone makes, but it's so simple to get right. Just remember, change the variable, change the limits. Okay, so how do we actually use this golden rule? Well, you've got two main strategies, two paths to victory. Let's start with method 1. I like to call this the teleport method. Why? Because it's super fast, super efficient, and it gets you straight to the answer by teleporting the entire problem into the U world and finishing it there. So here's the game plan for the teleport method. Step 1 is exactly what you're used to. Pick your U and find your du. Easy. But now look at step 2. This is the big one. This is our new move. We transform the limits from x values to u values. Once you do that, you solve the entire problem in the u world. You never have to go back to x, ever. All right, let's put this into action with our problem. First, we need to pick u. We can see that x squared plus 1 is the inner function, right? It's sitting inside the sign. And look at that. Its derivative, 2x, is conveniently waiting for us right outside. What a perfect setup. So it's a no-brainer. Let's make u equal to x squared plus 1. And when we differentiate it, of course, we get du equals 2x dx. And now, it's time for the golden rule. Let's transform our limits. Remember, the original limits, 0 and 1, were for the variable x. So, for the lower limit, when x is 0, what is u? We just plug it into our equation. U equals 0 squared plus 1. That's 1. Simple. Now for the upper limit, when x is 1, what's u? U equals 1 squared plus 1. That's 2. So our new limits in the u world are from 1 to 2. And just look at that. See? This is why the teleport method is so awesome. Our complicated-looking integral has completely transformed into something so simple. The sine x squared plus 1 became sine of u, the 2x dx became du, and our limits are now 1 and 2. All we have to solve now is the integral of sine of u from 1 to 2. How cool is that? It's a way easier problem.
Okay, let's finish this. We just have to solve this simple integral. The integral of sine of u is just negative cos of u. Now we evaluate this using our new u limits from 1 to 2. So we plug in the upper limit first, which gives us negative cos of 2. Then we subtract what we get when we plug in the lower limit, which is negative cos of 1. So we have negative cos of 2 minus negative cos of 1. Of course, the two negatives make a positive, which gives us our final answer. Cos of 1 minus cos of 2. And that's it. Mission complete.
All right, so that teleport method is pretty quick, right? But I know what some of you might be thinking. What if changing the limits feels a bit confusing? Hey, no problem at all. There is another way. Let's check out method 2, which I call the safe return method. This one might feel a little more familiar, like a path you've walked before. The strategy for this method is totally different. First, you just pretend the limits don't even exist. Seriously, just ignore them for a minute. You solve the problem like a regular indefinite integral using substitution. You get your answer in terms of u, and then, this is key, you back substitute to get the antiderivative back in terms of x. Only when you're back in the x world do you bring back the original x limits to evaluate. Okay, so applying this to our problem. First, we ignore the 0 and 1 and just find the indefinite integral. Like before, we set u equals x squared plus 1. The integral becomes integral sine u du. We know that integrates to negative cos u. Now, for this method, we have to back substitute. We have to return to the x world. So we replace u with x squared plus 1, and our antiderivative is negative cos x squared plus 1. Now that we're safely back in the world of x, we can finally use our original limits, which were 0 and 1. We apply these to our answer, negative cos of x squared plus 1. Let's do it. First, plug in the upper limit, x equals 1. That gives us negative cos of 1 squared plus 1, which is just negative cos of 2. Then we subtract the value at the lower limit, x equals 0. Plugging that in, we get negative cos of 0 squared plus 1, which is negative cos of 1. So the whole calculation is minus cos 2 minus cos of 1.
And what does that simplify to? Well, it's negative cos of 2 plus cos of 1, which is, wait a minute, exactly the same answer we got with method 1, cos of 1 minus cos of 2. And there it is. That's your aha moment. This proves that both methods are 100% correct. Both paths lead you to the exact same destination.
All right, mission accomplished. Time for a quick debrief. We've just seen two perfectly valid strategies to solve these definite integrals. So the big question on your mind is probably, which one should I use in my exam? That's a great question. Let's compare them side by side. So let's break it down. Method 1, the teleport method, transforms the limits and lets you finish the entire problem in the u world, no coming back. Method 2, the safe return method, keeps the original x limits, but makes you do that extra step of back substitution before you can finish. So which one's better? Honestly, method 1 is often faster, especially if the new u limits turn out to be simple numbers like 0 or 1. But method 2 can feel safer to some students because it's a lot like the process you already know. The most important thing, they both give you the same correct answer. So let's quickly recap the absolute must-know points. Number 1, at the top of the list is the golden rule. When you change the variable, you must change the limits. Don't ever forget that. Second, method 1 is usually faster, but method 2 is a perfectly good and safe alternative. And finally, please remember, a definite integral gives you a number as an answer, not a function. So no plus C here. So the final question is for you. Which method feels better to you? Are you on Team Teleport or Team Safe Return? The truth is, there's no wrong answer. The best method is simply the one you feel most comfortable with. So my advice is to try both on the next few problems you do. See which one clicks, and then get ready to totally ace this topic. You've got this.